Hello. Today we are doing lesson 2.7, solving absolute value inequalities. So last class we did absolute value equations. Now we're going to do absolute value inequalities. One second. Okay. So our objectives are to solve inequalities in the form the absolute value of x is less than a. It also can mean absolute value of x is less than or equal to a. And just like last class, a is just a number, right? So it's that same a from our last class, but instead of an equal sign, it's an inequality sign. And just like this could be less than or equal to, this one could be greater than or equal to a. There are rules we follow, and it will again be similar to last time. First, you want to isolate the absolute value, then you want to follow the rule, then you want to check your answer, or check one of your answers in your set. So here are our rules. Notice that there are two rules. They both start the same. If a is a positive number, okay, then the absolute value of x less than a is equivalent or equal to negative a is less than x is less than a. Negative a is just a's opposite, right? On the number line. Equal distance from 0. So if x is greater than a, then it is equivalent to x is less than negative a, or x is greater than a. So because we're going to be using these rules for every example, I'm going to write them down and carry them with me, okay? So I'm going to call this rule the less than rule. So if the absolute value of x is less than a, then what I write is the opposite of a is less than x, and x is less than positive a. Okay? For greater than, I left myself an over. If x is greater than a, absolute value of x is greater than a, then x is less than negative a, or x is greater than a. So those are the two rules we're using today. If I see this, I'm going to write this. If I see this, I'm going to write this. And very importantly, it is the same rule if it's equal to. Do you say less than or equal to? Greater than or equal to. Let's think about this. The less than rule. Let's say x is 3. Not what I meant to do. X is less than or equal to 3. Okay? Think about every value I could substitute in for x. Take the absolute value of and get a number that's less than 3. Maybe think about a number line that could represent this. The absolute value of x is smaller than 3. Maybe I'm going to put 4. What numbers on this line could go here? The absolute value is smaller than or equal to 3. Can't be -5, right? The absolute value of -5 is 5. That's not smaller than 3. Can't be -4. It could be 3, right? It could be anything smaller than 3 on the negative side. It could be anything smaller than 3 on the positive side. But it can't be bigger than 3. So we're saying it's between -3 and +3, right? Which is the same as our rule. The absolute value is less than or equal to 3. -3 is less than or equal to x. And x is less than or equal to +3. Now let's do it for x is greater than or equal to 3. So before it was between the number and its opposite on the number line, right? But now we're at greater than 3. So let's draw another number line. Maybe we'll have 5, 0. Where would it be on the number line if the absolute value was bigger than 3 or equal to 3? It couldn't be the same as this, right? It has to be bigger than or equal to 3, so it's kind of the opposite, right? If the absolute value is greater than or equal to a number, it is going to be all the numbers that are greater than that number, right? Anything greater than 3. Anything greater than or equal to 3, but also the absolute value. So anything less than or equal to -3. Because if we look here, the absolute value of -4, right, is greater than or equal to 3 because it's 4. 4 is greater than or equal to 3. The absolute value of 5 is greater than or equal to 3 because 5 is greater than or equal to 3, right? 0 The absolute value of 0 is not greater than 3. Let's pick some numbers here. Here we said it's between 3 and -3. So let's pick 1. Yeah. The absolute value of 1 is less than or equal to 3. The absolute value of 1 is 1. 1 is less than or equal to 3. Yes. Let's try -2. The absolute value of -2. Space. The absolute value of -2 is less than or equal to 3. The absolute value of -2 is 2. Yes. -5. The absolute value of -5 is 5. That's not equal to 3, right? So this graph is correct, and this graph is correct. And remember, the way we write it is -3 is less than or equal to x. X is less than or equal to 3. Down here, we would write it as x is less than or equal to -3, or x is greater than or equal to 3. Until I remember it. What number to which I need a number to which I can add 4, take the absolute value of it, and get less than 6. Okay, so step 1 is isolate, just like last class. Isolate. Done. That is alone. Step 2, look at the rule. Use the rule. This rule is the less than rule. So -a is less than or equal to x is less than or equal to a. So we have the absolute value of x plus 4 is less than 6. I'm going to take the -6, the -a is less than x plus 4. No more absolute value, bars, is less than 6. Isolate the absolute value bars, right? Because number 3 is isolate x. Or isolate your variable. Isolate your variable, you're going to want to subtract 4. Remember that we have 3 sides, the middle, the left, and the right. -6 minus 4 is -10. X 2, right? So -10 is less than x, x is less than 2. Graph it. X is greater than -10, and x is less than 2. Now let's test it. What's a number between -10 and 2? I like to use 0. If 0 is part of my set, that's the one I test with. So 0 plus 4 is 4. The absolute value of 4 is less than 6. Yes. Let's try one outside. +10. +10 should not be true. 10 plus 4 is 14. The absolute value of 14 is 14. 14 is less than 6. No. So I think my graph is okay. And then to use set notation, -10 not including to 2, not including 2. Your fourth step can be check. Check part of your, check one of the numbers in your solution set, okay? Or test it. Solve for x. Isolate the abs value by subtracting 6. The absolute value of x minus 3 is less than or equal to 1. Now I can apply the rule. Absolute value is less than or equal to a. So that means I need to rewrite it as negative a less than or equal to x less than or equal to a. Negative a would be negative 1. Now I'm going to isolate the x, or the variable. By adding 3 to all 3 sides. Negative 1 plus 3 is 2. Less than or equal to x less than or equal to 4. Okay. Let's check, see if that's true. So it can be any number between 2 and 4. So like 3. 3 minus 3 is 0. The absolute value of 0 is 0. 0 plus 6 is less than or equal to 7. Yes. All right. So now I can graph it. Here we have 2. Here we have 4. And it's going to be everything between, anything greater than 2, anything less than 4, right? Including. So maybe I should check one outside my set just to be sure. What's outside of here? 0. 0 minus 3 is negative 3. The absolute value of negative 3 is 3. 3 plus 6 is 9. 9 is not less than 7. So that will not work. And how would I write this in brackets? So including 2, starting at and including 2, ending at and including 4. Sorry guys, I think I called this set notation, it's interval notation. Example 3. We're still using the rule for less than. The rule for less than is absolute value of x is less than a. So negative a is less than x, and x is less than a. That's the rule we're using. It is isolated, so it is ready for the rule, right? So I could rewrite it, but do you see anything Do you see any red flags? Our rule actually says if A is a positive number, and if A is a positive number, right? And last class, when A was a negative number, what did we have to say? So this is 2.6. We say if A is a negative number, it has no solution, right? When we got to 3z minus 2 equals -7, because that's an absolute value, we said this is no solution. Distance cannot be negative, right? So the same is true here. If you have a negative A, the absolute value is less than a -2. That is not possible, right? A distance cannot be smaller than a -2, right? Even if I put 0 inside the absolute value bars, 0 is less than -2, that's still not true. So there's no solution to example 3. You can say no solution. You can say that the set is empty, there's nothing in it. You can just say this, no, not possible, okay? Example 4. All right, sorry if this video is a little pieced together, but it's taken 3 tries. I think we've got it now though. So for example 4, here's my rule for, we're still on less than, right? If the absolute value of x is less than or equal to a, then we set -a less than or equal to x, and x less than or equal to a. However, this number is 0. 0 does not have a negative. And can an absolute value ever be less than 0? An absolute value is a distance, remember, and a distance cannot be negative. So it will always be a positive number. It could be 0, right? 0 is 0 from 0. So that's a distance. But it can't ever be less than 0. So instead of saying the absolute value becomes greater than or equal to -0 or less than or equal to 0, all we can do with 0 is take this out of the absolute value bar and set it equal to 0. So for 0, remember our rule was when A is positive, right? If A is a positive number, right? 0 is not positive or negative. So for 0, we take it out of the absolute value bars. If it's less than, we just set it equal to 0, okay? So step 1, isolate the absolute value, right? I guess you could say isolate the absolute value of x, set equal to 0. Right? And then we're going to solve for x. For this one, the first thing we need to do to solve is find the least common denominator, right? Because we want to get rid of the fraction. the least common denominator, there's only one denominator. The denominator is the bottom of the fraction. There's only one denominator and it's 3. So the LCD is 3. Multiply everything by that. No, sorry. What I would rather do is distribute. Distribute the 2. I just looked at it. I was making my list before I looked at my problem. All right, distribute the 2. Distribute anything in through the parentheses. So I'm going to rewrite it before I multiply everything by 3. 2x, because 2 times x is 2x. And then plus 2 times 1 is 2. 3 stays the same. 0 stays the same. All right. Now we can multiply everything by the least common denominator. This is all one division problem. So I'm going to say it's one thing multiplied by 3. Everything on this side multiplied by 3, and there's only one thing, it's 0, right? So now we have, if I were to rewrite this, 3 divided by 3 gets canceled out. So now I have 2x plus 2, I'm going to put it up here, equals 0 times 3 is 0. All right, now I'm just going to solve for x. So for number 5, you could say solve for x. Subtract 2. Subtract 2 on this side. 2x is -2. Divide by 2. Divide by 2. X is -1. All right, and let's check our answer. So I have 2, just to put this all in the calculator. Slowly. 2 times -1 plus 1 is 0. Divided by 3 is still 0. And then is 0 less than or equal to 0? Yes. Okay. So that's an okay answer. And let's find out if x can be anything else. Yeah? What if x were 0? 2 times 0 plus 1 is 2 divided by 3. Is that less, is the absolute value of that less than or equal to 0? No. So we tried something in our solution set and something outside our solution set. So I think our solution set is good. We have tested our solution set. That's number 4. Number 5. We are now doing greater than rather than less than. Okay, so for the greater than symbol, well, let's not start with the root. Let's start with isolate x, or isolate the absolute value, right? So to isolate everything in the absolute value, I'm going to subtract 1 from both sides of the inequality. Absolute value of 10 plus 3x greater than 2 minus 1 is 1. All right. Now, if the absolute value of x is greater than a, I change that to x is less than negative a, or x is greater than a. So I'm going to take this and turn it into 2 different equations. 10 plus 3x is greater than 1. right? Or the same 10 plus 3x, flip the symbol, change the sign, is less than -1. Now I'm going to solve each side, or sorry, each inequality for x. So we call that number 2. When the absolute value of x is greater than a, change to x is less than -a, and x is greater than a. All right. Subtract 10, subtract 10. 3x is greater than -9. Divide by 3, divide by 3. X is greater than -3. Let's check that. X is greater than -3 here. What's a number greater than -3? 0. 10 plus 3 times 0. 0 is 10. Absolute value of 10 is 10 plus 1. 11 is greater than 2. So that one's okay. Ten plus 3x is less than -1. Subtract 10, subtract 10. 3x is less than -11. Divide by 3, divide by 3. X is less than -11 thirds. And if you put 11 thirds into your calculator, you get something between 3.5 and 4, right? Because -3.5 and 4, because -12 thirds would be -4. So does this work? It has to be smaller than -11 thirds. So let's just say -4, right? So 10 plus 3 times -4 is -2, but the absolute value of -2 is +2. So +2 plus 1 is 3. That is greater than -2. So that one's okay. The way we would graph this is we would think that was -3.6, right? I'm just going to draw my graph. I'm going to have the -3, and I'm going to have -3.6, right? It's greater than -3. X is greater than -3. So it goes that way. And x is less than -11.3, so that one goes that way. So if you notice, let's see if I can find all my old examples. All right, if you notice, if we're doing less than, it's going to go this way. Your graph is going to go this way. It's going to be contained in 1. And if we're doing greater than, you're going to go in opposite directions towards infinity. Example 1, we were contained between -10 and 2. Example 2, we were contained between 2 and 4. And now we're working this way. Which also reminds me to go back and real quick, let's look at what this looks like as interval notation. That same parenthesis, -10, 2. So here we have the inequality, the graph, the interval notation. Here is the inequality, the graph. The interval notation is going to follow the graph. That same bracket the number 2, it ends at 4 and gets the closing bracket. Okay. Example 3. I'm not going to be able to find all of these. All right, example 3 had no solution, so there is no interval notation. And then example 4 only had one answer, right? X is -1. So the whole set is X is -1. All right, example 6. Solve the absolute value of X plus 2 is greater than or equal to 0. But isn't everything greater than or equal to 0 when it's an absolute value? Yes, it is. All real numbers is your answer. Anything on the number line, when you add 2, will be greater than or equal to 0. And we're on to our final example. Example 7. So if the absolute value of X is greater than or equal to A, then take that, set it less than or equal to -A, and then set it greater than or equal to A. Okay, so we have isolated it. That's done. Set to, oops. Okay, instead of X, we're going to put this. Instead of A, we're going to put 4. So immediately, we can immediately go to the 2 separate inequalities without the absolute value bars. 7 plus X over 2 is, we'll go with this one, less than or equal to a -4. And then over here, 7 plus X over 2 is greater than or equal to 4. The same thing we have here. All right, so we have isolated the absolute value. We set it equal to those 2. Now we need to get rid of the fraction by finding the LCD. And it is the only denominator, which is 2. And then multiply by the LCD. Times 2, that's all one division problem, -4 times 2. All right. The reason we did that was to cancel those. So those are canceled. 2 divided by 2 is just 1. So that becomes 7 plus X. -4 times 2 becomes -8. And even though this is a -4, it's being multiplied by a positive. So we don't flip the sign. We only flip the sign if the one we added through multiplication or division is the negative. Okay. So the sign stays the same. Now I'm going to subtract 7. X is less than or equal to -8 minus 7 is -15, right? And over here, we're going to do the same thing. Multiply by 2. Multiply by 2. Those cancel. 7 plus X is greater than or equal to +8 this time, right? subtract 7, x is greater than or equal to 1. All right, let's put these into our inequality just to make sure. Smaller than negative 15. Let's go negative 20. 7 plus negative 20 divided by 2. Negative 6.5. The absolute value of negative 6.5 is bigger than 4. So that one's okay. Now we have 1, positive 1. Positive 1. Okay. For positive 1, 7 plus 1 is 8, divided by 2 is 4. So 4 is greater than or equal to 4. Yes. All right, let's graph these and you will be done. Here's my line. Here's negative 15. Here's 1. All right, x is less than or equal to negative 15. The bracket, because it contains negative 15. And then x is greater than or equal to 1. The bracket, because it contains 1, and it goes that way. Oh, almost forgot. And this, so this interval notation begins at negative infinity and ends at 15 and includes 15. So it begins at 1 and then ends at positive infinity. And positive infinity always gets a parenthesis. All right, and that is 2.7. Thank you.